subscribe and press this bell icon to never miss another lecture video. Hi, welcome to GATE ESE lecture. We are in lecture number 38 of signal system, and here this is your discrete time system, and here we are going to test for the stability, that is your stable system and unstable system. This same condition, same principle as that of your continuous time signals. So an arbitrary relaxed system is said to be both stable if and only if every bounded input produces bounded output. Same thing. Whatever things that you have studied in continuous time domain is the same thing, but there is a change in the expression. Same bounded signals are the step signals. Here the step signals will look like this. Yes or no? Impulse signal, it looks like this. Yes or no? Decreasing exponential signal, that means decreasing exponential looks like this, no? So it looks like this. Okay, in case of discrete time system, so bounded signals, these are the bounded signals, and unbounded signals are the ramp signals. Ramp signals looks like this, so it will look like this. In discrete time domain, obviously it will look like this. Okay, increasing exponential signal, it looks like this. Increasing exponential signal, that means it will be like this, something like this. Correct. So these are unbounded signal, these are the bounded signal. And coming back to the condition for the stability, the way that we had in our continuous time domain, we had h of t dt, the mod of h of t dt integration minus t infinity to infinity is less than infinity. That means it must converges and give a definite value. Similarly, here for condition for stability, instead of taking integration, we are taking the summation, that is n equals to minus infinity to infinity. The sum of the samples has to give a definite value for the stability. Now let's solve a couple of questions. We know the same method that you need to follow. Check for the LTI. Yes, it is not a LTI system. It is not a LTI system. It is a non-linear system. It is a time variant system. So it is not LTI and it is not LTI. You need to check for the specific input. The same way, if you give whatever the input to this x of n value, y of n will always come out to be within -1 to 1. That means whatever the value of x of n would be, whatever the value of input would be, response will be bounded. So whatever के अंदर तो bounded input भी दे सकते हैं. So if you are giving bounded input, you are getting response to be bounded. This is stable, but it is not an LTI system. So that is why you do, instead of doing this kind of experiment, that is h of n ka summation without doing that, you did a specific inputs test. Again, if here you also do the specific input test, and you can see here as that of continuous k barabar, if you're taking any bounded input, that means you are x of n, if you are taking x of n and you are getting y of n, which is nothing but x of minus n minus 2. That means output or the response of the system is, क्या करता है ये response system, क्या करता है सर, इनपुट को लेता है, उसको शिफ्ट और रिवर्सल करके दे देता है, शिफ्ट और रिवर्सल करके दे देता है. Absolutely correct. So if you take a bounded signal, for example you took this bounded signal, अगर ये shift होके फिर reversal हो गया तो ये unbounded हो जाता है क्या? नहीं sir. So whatever the bounded input you take, that means if you taking bounded input, if you are giving bounded input to this system, output will definitely come out to be bounded. So that is why this system is stable. Clear? This is what we have discussed in continuous time domain as well. Now the same question, this is one kind of question we solve in our continuous time domain. This is the same kind of question that we are going to solve here. That is h of n is nothing but is equals to b to the power n and a to the power n, where b, if it is b to the power n, it is n is less than 0, and n and a to the power n when n is greater than equals to 0. Then now we need to determine the value of a and b for the stability of a LTI system. That means we need to consider here that this is a LTI system and it is a stable system. Now I need to find out the a to the power n, a value and b value. It's very simple. You need to to do the summation. What is the condition for the stability? Sir, h of n, the mod of h of n, that is where n tends to minus infinity to infinity, this must be definite. Now let's find out this value. The summation of this infinite terms ka summation ka value will converges if mod of a belongs to 0 to 1. If your mod of a lies between 0 to 1, and your mod of b to the power minus 1 must lies between 0 to 1. B to the power minus 1 must lies between 0 to 1. Okay, then only this value will converges, and this value will going to give you value. Look here. Yes or no? So which is nothing but equals to constant. This will only happen if your mod of a belongs to 0 to 1. A must be lies between 0 to 1, and b must be greater than 1. Clear? This is your condition. Thank you so much for watching this video lecture. In the next video lecture, we'll get into FIR and IIR system, finite impulse response and infinite impulse response system. Till then, see you. Bye.